In section 2 of chapter 8, this is our graphing section. 2 and 3 are a graphing section, but I'm merging them into just one section. We're going to just do them all the same way. Things get pretty intense in this graphing section. I know graphing is never a favorite thing, but graphing the things that we're going to see this chapter, it's going to be a lot more than what you've maybe been used to. We're going to graph some pretty complicated looking equations, and they can be tricky because one really little change from one equation to the next can create a very different graph. There's not a ton of consistency in what we'll be doing in this section. The way that the videos or the notes are going to go through is I think that there are 4 different videos to watch. And in the first 3, we're going to look at one step of the graphing process in each of the videos. So you have 4 examples on your page, and we're going to do the first step for each of those in this video. And then in the next video, we'll do the second step for each of them. So we're going to kind of jump around a little bit. So when you fill things out, don't take up that whole space because we're going to be coming back to each of those. All right. So here we go. These are the types of equations that we're going to be graphing in this chapter. This is a screenshot from a graphing calculator, and if you have a graphing calculator, that's going to help you out a bunch. If you don't, you'll be able to borrow one of the ones that I have in my classroom, or if you can borrow a friend's, that would be great. When it comes to the test, everything on the test will be able to be done by hand, and there will be some things that I still expect to see done by hand. But having a graphing calculator will help you out and just help you make sure that you've got the right details. So these are rational functions because our word rational has ratio in it, and ratio means function, or sorry, not function. Ratio is fraction. So we have fractional functions. We have x in the top and the bottom of our equation, and that's something that we haven't seen before. And we have some different things happening. So the first thing that we're going to look at is, here's the graphs of those. I forgot that I put these on here. So you see there how we have some pretty different looking graphs. There's quite a bit of variety with what's happening in some of those. So it's a lot to take in these couple sections. All right, but we'll get through it. Okay. So the first thing that we're going to look at when we graph these functions is we're going to find out or decide whether there is what's called a vertical asymptote. And I don't know if we've talked about asymptotes before yet, but an asymptote is sort of like a boundary line. It's going to help us draw a graph. It's not a part of the graph. It's a line, a vertical line that our graph can get really close to, but it never actually touches it. And it's caused by x values. It's caused by having an x that when we plug it in, it would make us divide by 0. And you hopefully know that we can't divide by 0. That gives us undefined values. So the first thing that we're going to do is look in the denominator, the bottom of our function, and see what makes that 0. If anything makes it 0, then we have a vertical asymptote. So we're going to start with the simplest rational function that we could consider, and that's just y equals 1 over x. And there's our connection to the the inverse variation that we looked at in section 1. This is an example of that. Here we have x and y varying inversely. So what does that look like as a graph? So the first thing we're consider is a vertical asymptote. And that's only going to give us just a little bit of what we need to know about this graph. There's a lot more, but we'll see that in the following videos. So we're going to look for a vertical asymptote, and I abbreviate that as VA. So if you see VA, that's a vertical asymptote. And to do that, we take the bottom of our rational function, and we set that equal to 0. And this one's real easy, because if we set x equal to 0, we get just x equals 0. Okay, so x equals 0 is a vertical asymptote, and what we'll do with that to start with is draw a dotted vertical line at x equals 0 on our graph, and that's it. Okay, we found the vertical asymptote of that graph, and that's going to help us out when it comes to drawing that graph. So moving on to the next equation, y equals x over x squared minus 4. To find the vertical asymptotes, we just consider the bottom of that fraction, so x squared minus 4, and we want to know what values might make that 0, because we can't divide by 0. So we take x squared minus 4 and set that equal to 0, and we could solve that either by adding 4 to both sides and taking the square root, or by subtracting, or by factoring. I'm going to do it by adding and taking the square roots. But factoring is something that we're going to do a lot of in this chapter. Okay? So add 4 to both sides, take the square root, and x is a positive or negative 2. So in this case we have 2 vertical asymptotes, because a 2 or a negative 2 would give us a 0 in the denominator. So we're going to draw our vertical asymptotes at 2 and at negative 2. Looking at our next one, finding vertical asymptotes there, again, we just look at the bottom part of that. So our vertical asymptotes, to find those, we will set x squared plus x minus 6 equal to 0. We'll solve this by factoring. This factors into x plus 3, x minus 2. So x is a negative 3, and x is a positive 2. So we have vertical asymptotes at negative 3. Those don't look very good. Oh well. And at 2. Alright, not that complicated when it comes to just finding the vertical asymptotes. That's the first step. This last one is the nicest. It's got a pretty simple denominator. Okay, so again, vertical asymptotes. Set the denominator equal to 0. Add 2 to both sides. X is 2, so we have just one vertical asymptote at 2. Alright, so that's it for finding vertical asymptotes. You set the denominator equal to 0 and solve and see what x's give you 0, because those cause us a problem in the denominator, and those end up being x values that we can't plug in. So this is not a part of our graph, but it's going to help us draw our graph.